Okay, so hello everyone. So in this section, we will tackle about free falling bodies. So this will be our topic for today. Okay, so free falling bodies. So you might want to try the following experiment. No, simultaneously drop a coin and crumble a piece of paper from the same height. So if the effects of air resistance are negligible, both will have the same motion, okay, and will hit the floor at the same time. So in the idealized case, in this case, in which air resistance is absent, so such motion is referred to as free fall motions. So it is well known that in the absence of air resistance, all objects drops near the Earth's surface fall toward the Earth with the same constant acceleration under the influence of the Earth's gravity. Okay, so now if we will observe this, no, this billiard ball. So under the at initial time, our our ball here is in refer to this reference. Our distance here is will be equal to zero. No? So if we will drop uh, if we will drop towards from this to the downward motion, no? Due to it will move downward it because of the influence of our the gravity, no? So okay, so in simultaneously our in a time in a uh, in accordance with the continuous time, no, our distance of our billiard ball will be increasing, no? So this one is what we call multi-flash photo, no? Gi-investigate nila ang unsang behavior sa to ang ball if we will drop under the influence of gravity. Okay, so when we use the expression freely falling object, we do not necessarily refer to an object dropped from rest. A freely falling object is any object moving freely under the influence of gravity alone, regardless of its initial motion. Okay, object thrown upward or downward and those released from rest are all falling freely once they are released. So any freely falling object experience an acceleration directed downward regardless of its initial motions. So due to our gravity, no, gravitational force, so the freely falling object will be experience an acceleration. So the particle under constant acceleration is in terms of vertical direction. No? It is always a uh, vertical direction when the object is uh, exposed into gravitational force. So there are three kinematic tools that will be used in our solving the problem. So this one, just like the same as our x na our kinematic equation in terms of x direction, no? So when it comes to x direction, our di ba A man to, A ang atong gamiton. But in terms of y direction, vertical direction, atong gamiton siya in terms of gravitational acceleration, g, and also here, this one is g gyapon, no? Okay, so let's have an example. Example number 1. A €1 coin is dropped from the Leaning Tower of Pisa and falls freely from rest. What are its position and velocity after 1 second, 2 seconds, and 3 seconds? Considering this figure, no, we have the Leaning Tower. So our sketch for the problem will be look like this. So at initial time, well, when the time is equals to 0, our euro coin will be, our distance equal to 0 at refer to this uh, distance, no? So our measurement for the y, initial y or initial distance is also equal to 0. When this coin is dropped at a certain time, let us say time is equals to 1 second, there will be having the distance na, no, for our coin. Okay, at t is equals to 1 seconds. So under the influence of gravity, which is the 9.81 meter per second, so this coin will be have a motion toward down, towards or downward na motion. So it will create a distance in refer to this reference. So y1, so we don't have value, but we can get the value uh, in using the kinematic equation, no, for solving this problem. When the time is equal to 2 seconds, so our y also will be increased, no? So our distance here in refer to this will be greater than as distance from t is equals to 1 seconds. So at 3 seconds also, we have the y put. We can get the value for this using to this formula. Yf or y final is equals to y initial. So our y initial here is equals to 0. Okay, so it will be cancelled out. So the equation will be yf is equals to vyt plus minus gt squared. I mean, this one is 1/2 gt squared, no? Sayop lang. So using this equation here, we can identify or determine our y distance at t is equals to 1 seconds. We know that from here, our velocity, initial velocity is equal to 0. So since our velocity is equal to 0, it will cancel out this initial velocity. So ang mabili na lang sa ito ang formula is equals to 1/2 gt squared. So 1/2, where our g is equals to 9.81 and our time is equals to 1 seconds. Our y is equal to 4.905 meters. T is equal to 2 seconds. What happened for our distance? So it will be increased, no? So using also the this equation, so we have this equation, 1/2 gt 9.81 times 2 seconds, 2 squared, that is equals to 19.62. Also for the 3 seconds, we have 1/2 9.81 times 3 squared, that is equals to 44.145 meter. Okay, so for the question, velocity, what is the velocity after 1 second, 2 seconds, and 3 seconds? So we can calculate that using this formula, no? This one. So we know our initial velocity is equals to 0, so we could cancel out this. So our equation na lang may bilhin is By final, that is equals to gravity times time. So now we have By is equals to 9.81 times 1 second, that is equal to 9.8 meter per second. So for the 2 seconds, time is equals to 2 seconds. Our final velocity is equals to 9.81 times 2. That is equal to 19.62 meter per second. At 3 seconds, our final velocity will be equal to 29.43 meter per second. Okay? Let's have example number 2. A stone is dropped from a balloon at an elevation of 300 meter. 2 seconds later, another stone is projected vertically upward from the ground with a velocity of 75 meter per second. At what distance from the ground will the stones pass each other? Refer to this illustration. So let us say our stone that is at a location from the balloon that will be dropped at elevation of 300 meter. This one is our point 1, and there will be a stone that will be projected vertically upward. So this one is our point 2 also, and our initial velocity here is equals to 75 meter per second. Okay, so after these stones is dropped, and also this other stone will be projected vertically upward. At a certain time, these two stones will be pass each other, no? Let us say this reference lines mo nilang gipass, or mo nga line nga mo pass sila each other, no? Okay, so from here point to this line, and from this line to this line will be 300 meter, no? Elevation 300 meter. Okay, so in this reference line, morning stone nga magpass la each other. So let us say our distance here from here is equal to s. Let us say our distance here is s, and we can conclude that our distance here is equals to 300 minus s. So 300 minus s, so mo na yung distance. Okay, we know that this stone at point 1 will be dropped advancing by 2 seconds later, no? So this 2 seconds, so we can create some relation from this time 1 and also this time 2, no? Where our time 1 is equal to time 2 plus 2 seconds. So kani nag-advance man siya kuan, drop before ni nagkuan, before ni gi-project niya vertically upward. So kani siya ni drop na siya by ni drop na siya, no, in advance by 2 seconds later, no? So T1 is equals to T2 plus 2. So using our kinematic equation, that is VOT plus minus 1 half GT squared. Okay, so we could cancel out in terms in refer to this stone, no? We can cancel out our initial velocity since we don't have this initial velocity man. Gidrop pa man niya initially. So 1 half GT1 squared, or 1 half 9.81 T1 squared. So at point 2, we have this formula also. So VOT may plus, so this one is against, di ba, against by the gravity acceleration, gravitational force. So against siya, so mo na iyang notation here is minus, but here is along with the gravitational force man downward. So this one is positive sign or positive notation. So 300 minus s is equals to 75 times 2 minus 1 half gt t2 squared. So to say substitute, we know that our s here, that is equal to our 1 half 9.81 t1 squared kaning equation. But our t1 is equal to t2 plus 2. So mo na siya na imo siya t2 plus 2. That is equals to 75 times t2 minus 1 half g t2 squared. Or this one is 9.81. So if you calculate using your calculator, so we could came up for the time 2, no? Since our equation here is have a one variable na lang, no? That is time 2. Time 2 is equals to 2.963 seconds, where our time 1 is equals to t2 plus 2. So 2.963 plus 2, we have the time 1, that is equal to 4.963 seconds. Okay, so now we can calculate for the distance, that is equal to 1 half 9.81 4.963 seconds squared. S is equals to 120.82 meter. So from the problem statement, our what our trying to looking for is at what distance down, no, from the ground. So what distance from the ground will the stone pass each other? So this one, no, 300 minus s. So 300 minus s, 300, where our s is equals to 120.82. So we can get the value for distance from the ground, 179.2 meter. Okay, so that's all for the free falling bodies, and in the next section we will be discuss 2D dimension particle motion. Okay, that is the projectile motion, no? So thank you for your listening and have a good day.